Okay. So, we're going to pick up where we left off yesterday. And you'll recall yesterday we did the disk method. And the disk method happens when we've satisfied some initial conditions of the representative rectangle being perpendicular to the axis of revolution and touching the axis of revolution. If we go down that same questioning process that I used yesterday, we end up with the different scenario, which is the washer method. So it goes something like, is my rectangle horizontal or vertical? It's vertical, therefore I'm working in terms of x. Is it parallel to or perpendicular to the axis of revolution? It's perpendicular to, so therefore I have either a disk or a washer. Is it touching the axis of revolution? If the answer is no, then all of a sudden we get a washer. And we talked about this yesterday, but now we want to get into the nitty-gritty on how it works. If you'll recall, yesterday when I set up the equations for the disk method, I used a capital R. And I don't think you've probably ever seen that before or haven't used it commonly, but now you see why I use capital R, because in the washer method you have two different radii. Capital R, lowercase r. Capital R is defined as the farthest distance from the axis of revolution to a point on the representative rectangle. Okay, so you can see in my picture there with the big fat honking rectangle there, it's the farthest distance away. Little r is defined as the shortest distance from the axis of revolution to a point on the rectangle. Then you find the volume of that pineapple slice looking thing using the method we talked about yesterday. It's the volume of the disk minus the volume of the hole, which would be pi capital R squared times W minus pi little r squared W. And then that bottom line on that slide, I just simplified it to give you that. Now why did I simplify it? Because we're going to change the W into something else. What are we changing the W into?
dx.
dx, good, because we want a very thin slice. And we're going to move the pi out in front because it's a constant. Okay, so far. Great, just great. So here's a little picture. If, for instance, we want to take that little sliver-looking thing and spin it around that axis, it's not touching, the representative rectangle in yellow is not touching the axis of revolution, so we have a washer. And when you spin it, you get that crazy little shape over there on the right. You don't have to draw the shape on the right, but you will have to work with the stuff on the left. And you can see where capital R and lowercase r are in that picture. I didn't mean that as a joke, it just how the English happened to work. Another example. Start with the area on the left, which, by the way, at this point you should know how to find that area, because we've done that in 7.1. If you spin the representative rectangle, for some reason I put it over on the right, you get the blue thing, and then when you put it all together, you get the red thing. Okay? Okay. So, let's do it, shall we? There's the formula. Some of you are memorizers. You'll go home and memorize that formula. However, again, I would emphasize striving for understanding, because you still have to differentiate between all the different formulas that we've had so far. Big radius squared minus little radius squared. And you got your pi in there, and you got your dx in there. Are we good? Awesome. Let's do an example. We did this example already when we were doing area. That little leafy looking cat's eye thingamajobber. Square root of x and x squared. Now, because we're going to revolve it, we have to start looking at capital R versus lowercase r. So here's my capital R. It's the farthest distance from the axis of revolution to the top of the rectangle. And then lowercase r is the closest distance. All the rules that we've talked about still apply. Top minus bottom is still active here. That's how you find r. So capital R, for instance, is top minus bottom. Square root of x minus 0. But you're all fairly bright, so I'm assuming you're okay with me dropping off the minus 0, right?
Yeah.
Okay. Lowercase r. Top minus bottom. Square root of x, x squared minus 0. It's just x squared. Put all that together and we get that honking thing, which is quite solvable, either with a calculator or without a calculator. All right, and then now it's solved it again, 3, 5, or 10 if you care. Okay, great. I don't necessarily care about solving it. I'm assuming you can all do that. I'm more concerned about being able to set it up. Okie dokie. Now the fun begins. So we've done discs and washers around only the x-axis. Now we're going to see what happens when we move it around something other than the x-axis. We'll get to the y-axis in a little bit when we do horizontal rectangles. But I want to do this. And what is this? I'm going to take this region and revolve that around the line y equals 3. So it's not the x-axis. It's this line here. So the shape's going to look a little different than if I revolved it around the x-axis. And if you are good with visualization, you can picture what those two things look like. You're going to get tired of hearing me say this, but I'm going to go through it again. How I know that that's going to be a washer. Vertical rectangle means I'm working in terms of x, which is good because my functions are already solved in terms of x. It's perpendicular to the axis of revolution, so I either have a disk or a washer. It's not touching the axis of revolution, so now all of a sudden I know I'm doing a washer here. Are we good so far? Good. So I need two things. I need capital R and I need little r. Here's capital R, because that's the farthest distance from the axis of revolution down to the farthest point. I actually missed a little bit. It should be there. How big is capital R? Other way around. Yeah, still top minus bottom. The top is 3. The bottom is the blue function. So this would equal 3 minus parentheses. The blue is the line, 1/2 x plus 1. Does that make sense? Yes or no? Yes. Okay, good. Little r. This distance here. How big is little r? What's the top?
Y equals 3.
3, and the bottom is?
X squared plus 2.
Good. 3 minus x squared plus 2. What did I do wrong?
No parentheses.
Parentheses. Muy importante. That's Spanish for very important, in case you were wondering.
I thought it was math class.
No, it is. Doesn't mean we can't bring a little Spanish. That's the hard part, in my opinion. From this point on, it's just setting up your integral and then grinding out the integral. So the volume is equal to pi times the integral. From what to what?
0 to 1.
0 to 1 of capital R squared, 3 minus parentheses, fx plus 1, close parentheses, all of that squared, don't forget to square it, minus 3 minus parentheses x squared plus 2, close parentheses squared. That's little r squared. What am I missing?
dx.
Dx, very good. Okay. Any questions on how I set that up? It doesn't matter that my rectangle is below the axis of revolution. Whether it's below or above, if you stick with the idea of top minus bottom, you'll be fine. If, for instance, I want to spin that around the line y equals 1/2, now all of a sudden the area is above the axis of revolution, and your top and bottom changes a little bit. And again, I don't want to spend a ton of time talking about how to solve that, because I think at this stage you should all be able to solve that integral. Okay? Yeah, there it is. Okay, we got that all right. Okay. Now, I was going to stop there yesterday, but we'll continue on. Does everybody know what that thing on the left is?
It's a
Floppy disk. What's the thing on the right?
washing.
I didn't know if you've ever seen one of those before. That's a washing machine. Have you ever used one of those before?
Yeah,
Oh, very nice.
almost blew up the house by myself.
You almost blew up the house using the washing machine.
No, I wish that was true. That'd be so fun.
I almost blew up my apartment with the microwave.
How? What did you put in the microwave?
Mac and cheese, right? The microwave right? But you're supposed to put water in it. Not the water. It was bad. Like it started smoking, it was like yellow smoke. I opened it, it's just a blast of yellow smoke. I had to unplug it, I had to run outside. It was bad. Like, I put the cheese and everything, just not the water.
You ran outside with the microwave, or just you ran out by yourself?
I
You took the microwave with you, outside?
Yeah. And then like, dust.
Bad, that sounds bad. Most microwaves,
Dangerous things.
can't trust
No,
them.
it burned. It burned through everything. Huh? There's no microwave.
Yeah, that probably wouldn't happen with a washing machine.
Because it has water.
Yeah, it's got its own water. Probably the only thing that happened there is put the wrong soap in.
Maybe it overflows,
Like-
so
Like a red with white.
cleans out the whole house.
It fall. Mine fell.
It fell?
Yeah.
What do you mean it fell?
Because ours, it's like on the second floor, it's right before the stairs. And it's on like a platform that's like 3 feet high. And so it was shaking so much that it slipped off the platform and fell to the side and blocked the door.
That's awesome.
So we couldn't even get in and get back.
Burn the house down there? Oh,
We had to take the door out.
beautiful. Okay, so let's talk about how we could end up having to use a horizontal rectangle. So before we continue, figure out what this picture looks like. Either draw it by hand, or Desmos it, or use your calculator, but get a visual as to what's going on in this problem. Don't draw your representative rectangle yet, just get a picture of the region that we want to revolve. So theoretically, you should know what x to the 5th looks like, right? Because it's just like x cubed, but a little bit different. What's the line y equals 1 and y equals 32 look like?
Horizontal.
Yeah, straight horizontal lines, correct. So, we get this. And I'd like to spin that around the y-axis. So you have to ask yourself, do I want to use a vertical rectangle, which is what we've done in almost all the problems, or do I want to use a horizontal rectangle? If you use a vertical rectangle, it creates a whole world of hurt. For 2 reasons. Number 1, you need 2 integrals, because notice that partway through the problem, the bottom changes. It goes from the blue line all of a sudden to the red function. That would be bad. The second thing is, we don't know how to handle it yet if what is that thing? The representative rectangle is parallel to the axis of revolution. That comes later. So therefore, we're forced to do this as a horizontal representative rectangle. Which means, as soon as I get a horizontal representative rectangle, I know that my functions have to be in terms of y, so I would solve this to be the 5th root of y. Okay. Is my rectangle horizontal or vertical? It's horizontal, therefore I'm working in terms of y. Is it perpendicular to or parallel to the axis of revolution? It's perpendicular. Is it touching? Yes, so I have a disk. Beautiful. What do I need to know? The radius. I don't need a little radius. There isn't a little radius, or you could think of it as a way. The little radius is equal to 0. Are we good? Good. Plug and chug pi times the integral. From what to what? 1 to 32. Of.
Fifth root of y.
Fifth root of y, quantity squared. No, silly boy. dy. Got him.
Yes.
Knew I'd get somebody. Okay, fast fact, is the fifth root of y squared y to the 5 halves or y to the 2 fifths? It is to the 2 fifths, very good. Could you do that integral?
No.
Okay then, you better be able to. Any problems setting it up though? Notice when the horizontal rectangle, we're sliding those representative rectangles up and down, so we're taking y values there. Everything should be in terms of y. Function in terms of y. Values for the limits of integration in terms of y. A dy on the end. Pi stays the same. Pi is universal. It doesn't care if it's dx or dy. So I think I got all that in there. Oh yeah, and I was too lazy, so I FN'd it. 284.987.
Yeah.
Any problems? Beautiful. You see how this process then is getting more complicated. Discs and washers. Now discs and washers in terms of x or in terms of y. Horizontal, vertical lines. Then we're going to start looking at what happens when the representative rectangle is parallel to the axis of revolution. That's going to create a whole new world of it. Right? This we already know. Comparison of dy and dx, horizontal versus vertical. Brown rectangle, yellow rectangle. Brown rectangle, yellow rectangle.
He's joking.
Brown rectangle.
That's yellow.
Yellow,
They're all
yellow,
yellow.
yellow. Brown, brown, brown,
They're all
brown.
yellow.
No, they're not.
They're all yellow.
Oh, he's talking about this one. Oh, yeah.
Oh, I
No, no,
thought-
top right, no, not
Oh,
representative
okay.
rectangle.
Okay.
Yeah. Yellow, yellow.
Green,
Brown, brown.
green, gray, yellow.
Brown,
gray.
yellow.
That's
There
green.
you go.
That's green. That's green. Son.
Yeah, that's
I see how it's going to be. All right, so I got this guy. Took a parabola, moved it up a little bit. Spin it around the y-axis. Can't do it with a vertical rectangle because that's the method we haven't learned yet. So I also noticed I just lost my N in revolution. Revolutio. It's Italian. Yeah, Italian. Revolutio. A lot of times when you're solving these problems, you can be sneaky. We looked at one the other day where we were finding an area where it was symmetric, so you could find just half of it and double it. This one you can also be sneaky. What shape is this figure from here down? It's a cylinder. So you don't have to do calculus for that part of it. You could just do geometry. But if you're feeling saucy and you want to do the calculus, go right ahead. The top part, you definitely need some calculus there. That would be a horizontal washer. Okay. We're not going to do it, but I just wanted to show you where these problems can go. Okay. I did do it, however. If you want to come back and look at it later, you can. That's how ugly it is. Which really isn't that ugly. It just turns into this, which then goes to that, then goes to this, and then you work some magic and you get that 3 pi over 2. I went through that quickly, but again, you got this under control, yes? We'll stop there. Okay, so tonight's homework is finishing the homework from yesterday. So there were some problems yesterday that you couldn't do because we haven't talked about horizontal and or the washer method. So you should be good to wrap up 106. Technically speaking, that 106 will be due on Monday because tomorrow we have the quiz on area. 7.1 area only. It is non-calculator. Okay. We good? Questions? Monday we'll pick up where we left off because we have to do some fun stuff like look at what happens when the rectangle is parallel to the axis of revolution.